Hello, I'm Bukola Joseph. I'm here to tutor you on vector addition. Actually, the recap on that vector addition. We have done vector addition, but I still want to do a recap so you'll be on the same page with me. Now, in vector addition, there are 4 rules you need to know when it comes to vector addition. Just like the name implies, vector addition is simply the addition of vectors. Okay, a vector is simply represented with a straight line, and the direction is denoted with an arrowhead. Now, the 4 rules that guides the addition of vectors. 1, if the vectors are acting in the same direction, let's say this is vector A and this is vector B, they are acting in the same direction, we do the algebraic sum. For instance, if this is 4 Newton and this is 3 Newton, the resultant will be 4 plus 3, which is equal to 7 Newton. Rule number 2, if the vectors are in the opposite direction, what does that mean? If the first vector is moving in this direction and the other vector is in another direction, let's say this is vector 4 Newton and this is 3 Newton, the resultant is equal to 4 minus 3. Our resultant then will be equal to 1 Newton. Rule number 3, if the vectors, the 2 vectors, are inclined at 90 degrees, sometimes you get to hear perpendicular. That means if the 2 vectors are perpendicular to each other, we use what we call the Pythagoras theorem to solve. So, if the 2 vectors are inclined, it means it's going to be this way at an angle 90 degrees. So, if we complete this, you have something like this. And of course, the resolution or the resultant will be from the common point. This is the common point. So we complete it and then we have this. This is our resultant. So to find the resultant in this case, if this is 4 Newton and this is 3 Newton, we have R is equal to, Pythagoras theorem is simply R squared is equal to A squared plus B squared. Okay, so if 4 is equal to A, or rather A is 4 and this is B, we have 4 squared plus 3 squared. This is the same thing as what? 16 plus 9, which is equivalent to what? 25. Then R will be equal to the square root of 25. R is therefore equal to 5 Newton. So our R is equal to what? 5 Newton. Okay. Now, if you have this kind of vectors that is inclined at 90 degrees or perpendicular to each other, and you are asked to find the direction, we can also find the direction using, so let's use what we have here. You remember your SOHCAHTOA? Using SOHCAHTOA, we can find the direction. Okay, so this is the direction. Let's say this is theta. You can find the direction using what? Sin theta is equal to opposite over hypotenuse. If this is our angle, theta, sin theta is this. That's opposite over hypotenuse. Of course, you know that the opposite side will be equal. This will be equal to 4. This also will be equal to 3. So we have 4 all over. We have opposite over hypotenuse. We have gotten our hypotenuse to be 5, so we have 4 over 5. Then we have theta is equal to the sine inverse of 4 over 5. And then you get your answer. Then, if you are to, there's another way we can find this. Let's not solve the problem. I want you to get the formula. to get the formula. So we have this, for instance. Let's do it this way so you get how the formula is being derived. So let's say this is the y direction and this is the x direction. This is the angle we're looking for. Are you here? So we have, using SOHCAHTOA, we have sine theta is equal to, this is y, this is x, opposite, the opposite is y, we have y over hypotenuse. Hypotenuse is our r, but let's say it's our f, our force. Okay, let's take it to be our force. So we have y over r, f. So if you cross multiply, we have f sine theta is equal to y. So it means, let's take this to be equation 1. It means that y is equal to f sine theta. So we use cos theta too. Cos theta is what? Adjacent over hypotenuse. That's what? X over f. If we make f the subject of math, we have f is equal to, okay, we have f cos theta is equal to x. Let's call this equation 2. So it means if you are asked to find the direction, you simply use this formula, knowing fully well that your f now is your resultant. So you just input your resultant here and then sine theta, and then you find, you put your f, which is your resultant, you put your y, and then you find the sine inverse, and then you get your direction. Now, rule number 4. Now, rule number 4. If the two vectors are inclined at an angle less than 90 degrees, if the two vectors are inclined at an angle less than 90 degrees or at an angle greater than 90 degrees, that means if the two vectors are inclined at an angle which is less than 90 degrees, that's called the acute angle. And if it is at an angle greater than 90 degrees, which is what we call the obtuse angle, we use the Pythagoras theorem to solve. Okay? So generally, the formula being used is called the cosine rule. And the cosine rule is simply that if the two vectors are inclined at an angle, less than 90 degrees or at an angle greater than 90 degrees. So this is synonymous to acute angles, and then this is what we call the obtuse. The obtuse angle. Okay? If it is less than 90 degrees, your diagram will look this way. Your two vectors diagram will look this way. Let me extrapolate this. You have this showing you that it is less than 90 degrees. So this is what? An acute angle. So if it is greater than 90 degrees, you'll be having something like this. The two vectors will be in this form, showing you that this is what? An obtuse. So if I want to make it clear, if this is 90 degrees, you can see that, yeah, it is greater than 90 degrees. So in this case, we use cosine rule formula, which is simply r squared is equal to, if here is a, this is b, we have what? A squared, a or b, plus what? B squared minus 2ab cos theta. This is cosine rule. So what does it mean? If, let's say, if a is 4 and b is 3, let's say, because I can't remember what I used in the first two cases. If a is 4, it means anywhere you see a, you replace it with 4. Here will be 4 square then plus 3 square minus 2 times 4 times 3 cos theta. Usually, an angle will be given. And whatsoever angle you are given, let's say you are given for this one, you are given 55. You do 180 minus 55. Then you use 1. Okay, let me just put the formula as 180 minus theta to make it easier. And then you solve to get your resultant for angles. For angles that are inclined at an angle less than 90 degrees and greater than 90 degrees. Okay, for today, I just did a recap, a previous knowledge on this. We've done this in the last video. But the bone of contention for today is resultant of more than 2 vectors. Now, we've been talking about 2 vectors. What if we are having more than 2 vectors? How do we find the resultant? There's a rule also. Okay? So now let's check out this problem I'm going to look at, where we have 4 coplanar forces acting on a point. Let's see how we can tackle problems like this, where you have 2 or more vectors acting at a point. How do we find the resultant? Come with me. So if you have this vector, let's say this, you have this. You have these vectors. Okay, these are not the vectors actually. Let me put the vectors in between. Let's say we have this. Let me put one here. Okay, and then put one here. Hello, are you with me? Okay, let me also put one here. Okay, we have 1, 2, 3, 4, 5. Yes. Now, when you see a question like this with vectors more than 2, don't panic. A step at a time. You take a step at a time. This is what we do first. You label each vector. Okay, let's start with this one. Let's call this one F1. Let's call this one F2. This one is not a vector. The ones with arrowhead are the vector. So we have, let's call this F3. This is not a vector. Let's call this F4. And finally we have the F5. Now, the rules guiding resultant of more than 2 vectors. When you are faced with this situation, use the principle of graphing. If you still remember how graphing is being plotted, okay? When you are, we will resolve all these vectors into the vertical component and its horizontal component. That's the first thing we will do. Okay, we'll resolve it into what? Horizontal component and vertical component. Okay, so we will start by resolving what we have, these 5 coplanar forces, into vertical components. Let's start with vertical components. Okay. Let's start with the vertical components. So right here, vertical components. Hello. So now if you have this, the vertical component, these 5 forces, we are going to resolve them into the vertical component. Now the rule for resolving into vertical components, okay? When you are talking about the vertical component, it means the y-axis. Okay, the y-axis, and everything that has to do with the y-axis, it means we are going to be looking at sine theta all through. You are going to be considering sine theta all through. Let me bring you back here. You can see we have y, and here we have sine theta. You see the x, cos theta. So anything that has to do with resolving into horizontal component is going to be cos theta, cos theta, cos theta. And when we are resolving into the vertical component, it's going to be sine theta all through. Let's go. So now, resolving into vertical components, all the vectors that are up will be considered as positive. Are you here? Every vector that is up will be considered as what? Positive. While every vector down will be considered as what? Negative. Let's go. Let's start with F1. Now, F1 is... Okay, let me put the angle. Okay, if you are considering the angle, usually you'll be given the angles. Okay, for when it comes to what resultant of more than 2, you'll be given the angles. Okay, so let's call this one theta 2. Okay, let's call this one, because theta 1 is on the horizontal, let's call this one theta 3. Let's call this one theta 4, and let's call this one theta 5. You need to know something. When considering an angle for a particular vector, it is the angle between the vector and the horizontal that is being read. I repeat, the angle between the vector and the horizontal that is being read. What does this mean? Even if you are given